Here I have a piece of annealed copper wire. If I try to lift the head of this hammer with it, you can see it just bends. Pure copper is soft, and that's why it's normally alloyed with other elements to increase its strength. But we can also make it stronger by cold working it. Now when I try to lift the hammer, the wire doesn't bend. By cold working it, I made the wire stronger, but I also made it less ductile. I can bend the tip of the wire, but if I bend it back, it just breaks. If I do the same thing with a piece of annealed wire, I can bend it back and forth several times. If I want to restore the ductility of the wire, all I have to do is heat it with the blowtorch. To understand what's happening, we need to look at the atomic level. Starting out, the crystal structure of the wire is well ordered like you see here, but when I hammer on it and plastically deform the wire, I create dislocations in its crystal structure. These dislocations tend to repel each other, making the wire stronger. The more I deform a material, the more dislocations I create and the stronger the material becomes, until eventually the material becomes so saturated with dislocations that it can't handle the stresses and it breaks. This is what happened when I bent the tip of the wire. When I heat the wire, the atoms start to vibrate and move to repair the dislocations. This restores the crystal structure and the ductility of the wire. And just like that, the copper is soft again.